There we go. All right. So again, we're talking about differential equations, and I did not actually say this, so I will say this now. Differential equations is basically like, it's the calculus, but it's applied in a lot of different areas of things. So like physics uses it, chemistry uses it, geology uses it. It's basically we can relate these rates with things that we know, okay? So it's used in engineering a lot. If anyone's going into engineering, you will take a literal class called DiffEQ, which is after Calc 3. So this is kind of a little intro to what you're going to see, basically, okay? So, really quick, direct variation and indirect variation. Oops, there we go. Okay, I'm going to highlight these things again here. So direct variation, your formula is f of x equals k times x, or y equals k times x, where k is my constant of proportionality. Oops. Okay. And then our inverse variation happens when we have our constant divided by x. So f of x equals k over x, or y equals k over x. And again, k is your constant of proportionality. And then there's a few other ways that we can say this. Y varies inversely with x, or y is inversely proportional to x. For direct variation, y varies directly with x, or y is directly proportional to x. Those variables might change in the examples that we're going to do, but basically it all means the same thing. Okay? Other thing to remember is in math, whenever you see the word is, what operation are you what symbol are you going to use? An equal sign. Okay? There will also be a few things that'll say something about difference. If it says difference, what are you going to use? Subtraction. And if it says sum, what are we going to use? Addition. Okay? If I said, what is the square of k, how would you write that?
K squared?
K squared. Yep. And if I said the square root of k, then you would write literally square root of k. Okay? Different kind of things there. All right. So backtracking up here. Differential equations again. Differential equations have x's in it, has y's in it, and it has derivatives of y in it as well. There are not always just one solution to a differential equation. There might be a set of functions. So there's a general solution, which we'll talk more about when we do the graphs and stuff next class. You'll be able to see a little bit more of what I mean by that. But here's some examples of what differential equations might look like using 3 different types of notation with little tick marks here. That still means that it's going to be the first or second derivative there for the first one. This is the second derivative. This would be my first derivative, and then this is just the function y. Okay, same thing here. This is my second derivative followed by my first derivative and just my y value. And no, it's not always in that order, but it just so happens that these 3 are. Just this is a different notation. This is also still the second derivative, just written differently. And then also this one we'll see a lot too. This is also my first derivative. Okay. So in this first little section here, we are just going to do 5 different examples of how to write equations given basically 2 or 3 sentences in terms of our constant of proportionality. So every single equation should have a k in it. Got it? So if I read this, it says a particle moves along a straight line. Its velocity v is inversely proportional to the square of the distance s that it has traveled. Which equation describes this relationship? If I go back, read this again, I'm going to highlight some important things here. It says velocity v is meaning equals. Okay, so I've got velocity. So our function velocity v of t is inversely proportional. Inversely proportional, is that going to be multiplying or dividing? Dividing, okay? And then to the square of the distance s. How would I write the square of the distance s? S squared. Okay? So looking at these options here, I can get rid of some options right away. Which options can I get rid of? Get rid of A, why? Because it has a T in it. We don't need a T in there. What else could I get rid of? C, because it also has a T in it. And now the difference between B and D is what? Yeah, derivative versus just the velocity. Which one are we talking about? B. Just the velocity. We are not talking about the rate. Keyword is usually it'll say something about a rate changing, and that's when you're going to have your fraction dv over dt or v prime of x. Okay? Questions on that one? All right, moving on, next page. Nice little puppy picture here. How many of us have dogs? Yeah? I want one so bad, but I've never owned a dog. No? You don't like, oh, we've had this conversation before. You like okay with it, but nah.
Yeah.
Mr. Lorson hates dogs. Okay, maybe hate's a strong word. He will never have a dog. But he won't ever pet a dog either. Weird, right?
He's just scared, that's what it is.
Probably. Okay, so we've got a puppy that gains weight, W, at a rate approximately inversely proportional to its age, T, in months. Write an equation that describes this relationship. Now, it sounds really scary, but if we go back through it, I bet you're just going to be fine. It's gaining weight, W, at a rate. Okay, so how would I write that portion? Yeah, dW over dt, because we're gaining weight after a certain amount of time. But then it says it's inversely proportional to its age, t. So I've got my dW dt, and that is inversely proportional to its age. We need to have a k in there. So what would my other side of my equation look like?
K over T.
K over t. So that is the relationship between the weight that is being gained and the time that we are occurring in months. Okay, example 3 says, the learning rate for a skill, S, is proportional to the difference between the maximum potential for learning, which is M, and then the amount of that skill that's already learned, L, right? An equation that describes this relationship. So we're given originally here a learning rate, S. So how would I write the left-hand side of my equation? ds over dt. And then it is proportional, so equals. And then if it's proportional, are we multiplying or dividing? Multiplying. And then it's proportional to the difference between the maximum and then the fact that it's already been learned. So I've got K, and I'm going to times that by what in my parentheses there? M minus L, because it says the difference. Okay, so we're subtracting there. Okay, example 4. We got to use our brains a little bit here. It says an IV drip administers medication to a patient's bloodstream at a rate of 3 cubic centimeters per hour. At the same time, the patient's organs removes the medication from the patient's bloodstream at a rate that is proportional to the current volume of the medication in the bloodstream. Okay, so all 4 of these options have dV dt, so I can't get rid of anything right then and there. But if we think about this logically, 3 cubic centimeters per hour is going in to start, right? And then the bloodstream is coming out at a rate that is proportional to the current volume. So the part that I have underlined there in blue, how would I write the rate that's proportional to the current volume V? How would I write just that piece?
dV dt.
Not dV dt, multiply, where I have K as my constant of proportionality, and then I times that with my volume. Okay, but then I start with the 3 cubic centimeters per hour, but we're taking out that K times V. So which one of those 4 options do we think is going to be our answer? A. Okay, there's another one that I could get rid of right away, which I forgot to mention. Which one do you think I could get rid of right away and why? D, because? There's no K, right? Every single one of these has to have a K in it because that's our constant of proportionality, okay? All right, and lastly here, I'm going to let you guys read this one and see if you can choose, using those deductive reasoning skills, A, B, C, or D, which one would be the best option. And then we'll go over it. Okay, so if I read through this, we're given that the volume at any time is 20 plus 2t. And the next sentence is really like the actual thing that's happening. So it says the amount Z of a chemical in the tank is decreasing at a rate that is proportional to Z and then inversely proportional to the volume. Okay? So decreasing is going to be what?
Negative.
Negative. This is going to make it negative. And then it says a rate that's proportional to Z. So proportional to Z would be K times Z. And then if it's inversely proportional to the volume, we would divide that by my volume. But what is my volume?
20 plus 2t.
20 plus 2t at any time, right? So this should be 20 plus 2t. So of those options that I've got, that would be letter A. Letter D is the exact opposite of that. If it was directly proportional to Z, or sorry, to 20, or sorry, to the velocity, and then inversely proportional to Z, that would be for example D. Okay? Alrighty. Now, we're going to do a little whiteboard practice over some of these. Okay, they're going to start out kind of easy, get a little difficult, mostly just because there's a few more words in it, but it's really not that bad. So if you guys want to grab whiteboards, markers, and erasers, you can. If you want to write on your desk, you can. If you want to go up to a whiteboard and stand up, you can write up at a whiteboard if you want. Just preferably not the front whiteboard, because then everyone's going to be looking at your answers. And then I will pull up the problems up on the TV. All right. So if I zoom in here again, remember a solution to a differential equation is satisfied when your y and derivatives are replaced into the differential function that we're given. Okay? So example 1, we're verifying solutions to the differential equation. Determine whether the given function is a solution to the differential equation f double prime minus f of x is equal to 0. Okay? So this piece right here is my second derivative, and this piece right here is my f of x function. All three of the things that were given here, a, b, and c, those are all what? First derivative, second derivative, or just f of x? So those are all f of x, right? So we're literally going to plug these things into that equation in a little bit, okay? Next thing we need to do is find my second derivative, okay? So if I zoom in here, we're not doing integrals. Got to flip back our brains. We're doing derivatives. So what would the first derivative of sine be? Cosine. Okay, what is the second derivative of cosine, or sorry, the second derivative of sine, or the derivative of cosine?
Negative sine.
Negative sine. Okay, so now I'm going to plug this and my sine of x into my function that we were given for our differential equation. So I've got my f double prime, so that's negative sine of x. And then minus my f of x function, which is sine of x. And that equals 0. That's what we're checking. Again, this is from this equation over here, our differential equation. We plugged in our second derivative, our f of x function. Does this make sense? Is negative sine of x minus sine of x equal to 0? No. If that was a plus sine of x, or if it was a positive sine of x for my second derivative, then it would be equal to 0, right? So this is not true. Okay. So therefore, this is not a solution to my differential equation. I'm going to abbreviate differential equations with DE.
You gotta draw it like that every time.
Okay, letter B, we gotta remember chain rule. Do we remember chain rule? Okay, go ahead and try taking the derivative, the first and second derivative of letter B. All right, I'm gonna write my first and second derivatives up here. Do we agree? Okie dokes. Now I'm gonna plug this stuff in. Oh, I meant to write it in red. I didn't, though. That's okay. This is going into my equation for my second derivative. So I've got 4e to the negative x minus 4e to the negative x. Does that equal 0? Yes, it is. So this is a solution to my differential equation. Okay? One of the many solutions that are possible for this one. Oops. Okay, letter C. What's going to happen when I take my first and second derivative here? They're going to be the exact same both times because C is just a constant. And if we take and plug this value in and I subtract my f of x function, is this equation true? Yes, it is. Therefore, this is a solution to my differential equation. So that's just verifying whether something is a solution or not. Given your differential equation, you just plug those values in. Questions on that one? Okay, example 2. It's written a little bit differently, but we're determining, again, still whether this is a solution, but it's written as dy dx is equal to 4y over x. The first thing that I'm given is y equals 4x. What do you guys think we're going to do first?
dy?
Yeah, what is dy dx of a? If I took the derivative here, just 4, right? Okay, so we're looking to see if this is going to equal what I get when I plug in, my y value, which is 4x. Okay, so I'm using my differential equation formula here. I've got dy over dx is equal to 4 times y. Don't I know what y equals? 4. Not just 4, but 4x, right? So I've got 4 times 4x, and we're dividing by what from my formula? From my differential equation? X. Okay, what do I get when I simplify 4 times 4x over x? Just 16. Does 4 equal 16? Nope. So therefore, this is not a solution. Okay, you guys think you can do letter B? Yeah? All right, try it out. Check with your neighbor when you're done. Then I'll just go ahead and say that 4x to the third equals 4x to the third. Oops, that was a weird 3. So yes, this is a solution to my differential equation. Okay? All right, now this is my favorite example of today because it just brings back some algebra. It's just fun. So we're looking at what values of k, if any, is y equals e to the 2x plus k e to the negative 3x, a solution to the differential equation there that we're given. So 4y minus y double prime is equal to 10e to the negative 3x. What is the first step that we're going to have to do here? Find what? Find the derivative, just the first derivative? No, second derivative. So find the first and second derivative. Check with your neighbor, see if you got that answered. Before we move on, we got to make sure we have the correct first and second derivative. Make sure you are using your chain rule, which I know is everyone's favorite thing. So don't forget that. I might make one on purpose.
Shouldn't it be constant, but a 2 on the first derivative?
Yeah, I made 2 mistakes there on purpose for you guys to fix for me. What do we got? This should be a 2. I agree. Do you guys agree? Yeah? Plus 9. Oh, I actually made 3 mistakes. And then what else?
That should be a 4e.
Nice. You guys remember when you were like really bad at chain rule? See? You're so good at it now. All right. Now we're going to go ahead and take this double prime. Oops. This whole thing right here. Plugging that in for y double prime. And I know my y function is equal to this. So I'm going to plug that in for y. And now it's literally just algebra. Okay? No more calculus is needed. We just need to solve our function for k. So let's carefully plug these things in parentheses. Please and thank you. 4 times e to the 2x plus ke to the negative 3x. And then this is usually where people forget to to put their parentheses because they're like, we're just subtracting this whole thing, but you're subtracting the entire quantity, right? So we got to distribute that negative. Oops. And this whole thing is equal to 10e to the negative 3x. It's a little small. Okay, what do I gotta do first? I'm just doing algebra. Distribute. Distribute both things, right? So I'm going to distribute the 4. This becomes 4e to the 2x plus what? 4ke to the negative 3x. If I distribute that negative, it's going to make both of those negative. And now I'm going to let you finish that out. Okay, go ahead and combine your like terms. Solve for k. And your answer should be one of the ones that are there. K is equal to negative 2 after you've solved all of that fun algebra stuff. Okay. And that is all I have for you guys today. So first thing we're going to do is we're going to take a little 5-minute break. But then after that 5-minute break, we're going to come back and then we are going to do the homework in reverse order. So starting with problem number 8, going back up to problem number 1. Because I'm going to help you guys out with the last 3 because those are actually the hardest. So we're going in reverse order for the homework here. In about 5 minutes, I'll put a timer up here for you guys, and then we'll get back together.